Mountain of Roses.
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 Roses, everyone.
So I choose magnesium that has an atomic mass of 12 or electron of 12. In order to find the electron configuration, you must know and understand each energy level and subshells. So S can take up to 2, P to 6, D to 10, and F to 14. Again, magnesium has an atomic mass of 12. In order to find the electron configuration, we must copy each energy level until 12 because magnesium has only 12 atomic mass. Now let's add all the number of electrons. 2 plus 2 equals 4, plus 6 equals 10, plus 2 equals 12. So in short, this configuration is correct because magnesium has an atomic mass of 12. So this electron configuration is correct. Now in finding the noble gas electron configuration, we must remember all the noble gases, which has helium has atomic mass of 2, neon has 10, argon has 18, krypton has 36, and so on. Again, magnesium has an atomic mass of 12, and put in mind that you have to remember the electron configuration of magnesium in order to find the noble gases electron configuration of a magnesium. Now we are going to look at the elements that belong to the noble gases and observe what elements that has an atomic mass of below 12. Obviously, we will be using neon since neon has an atomic mass of 10. Next is you will just cross out the number of electrons until 10. So magnesium has a noble gas electron configuration of neon 3s squared. Now in valence electron, you just have to copy or add if there are 2 or more energy level outside the noble gases. So our valence electron is 2.
So I choose the symbol I, which stands for iodine. So in order to find the electron configuration, we must search it in periodic table. So let's start. So this is the S side, and also the helium is S side. This is the D side, and P side and F side. So we'll find the electric configuration of iodine by starting from hydrogen and making on our way to iodine. So first so let's start. So 1s2, 2s2, 2p6, and then 3s squared, and then 3p6, and then 4s squared. So now we are in the D block, and the coefficient or number in front is always 1 less than the row it is in. So instead of 4D, this is actually 3D. So let's begin again. So this is 3D10, 4p6, 5s2. So what I said earlier in the D block is always 1 less than the row. So this is 3. So this is 4. So 5. This is 4. So 4D10, and then 5p5 because we're in the iodine. So in finding valence electron, it's the same to electron configuration. So I copy paste it. So the highest valence electron is 5s and 5p5. So valence. So how I get valence electron? So I add their exponent, who is I add the exponent of the largest number in valence electrons. So 2 plus 5 equals 7. So how will in noble gases? So I stands for iodine. So I copied the electron configuration of iodine, which is 1x 2, 2s squared, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5 So in order to find noble gases of krypton, why krypton? So the number of iodine is 53. So we must find noble gases that is less than 53. So the noble gases that has less than 53 is krypton. So we must find the electron configuration of krypton, which is 1s squared, 2s squared, 2p6, 3s2, 3p6, 4s squared, 3d10, and 4p6. So, and then last crush out the same number of which is the iodine and the krypton have. So crush out, and then crush out, and then the remaining number is 5s squared, 4d10, 5p5. So, and then, so the noble gases of iodine is krypton, 5s2, 4d10, 5p5. That's all. Thank you.
Denobrosis. I'm James Laurito and I'm assigned for sulfur. Sulfur is a chemical element with the symbol S and atom number 16. It is abundant, multivalent, and non-metallic. Under normal conditions, sulfur atoms form cyclic octatomic molecules with a chemical formula S8. Element sulfur is a bright yellow crystalline solid and room temperature, and the next one is the valence of sulfur. Sulfur can follow the octacrules as in the molecules SF2. Each atom is surrounded by 8 electrons. It is possible to excite the sulfur atom sufficiently to push valence atoms into the d orbital to allow molecules such as S4 and Fs6. The sulfur atoms in SF4 has 10 valence electrons and 12 valence electrons in SF6. And the last one is the noble gases of sulfur. Sulfur has 16 electrons. The nearest noble gas to sulfur is argon, which has an electron configuration of 1s to 2, 2s to 2, 2p is to 6, 3s to 2, 3p is to 6. To be isoelectronic with argon, which has 18 electrons, sulfur must gain 2 electrons. Therefore, sulfur will form a 2 ion become S2 negative. And that's all. Thank you.
Montenobrosis. So I choose Na, which is sodium. So now I'm going to explain what is electron configuration for sodium. In writing the electron configuration for sodium, the first 2 electron will go in the 1s orbital. Since 1s can only hold 2 electrons, the next 2 electrons for sodium go into 6 electrons. We'll put 6 in the 2p orbital and then put the remaining electron in the 3s. So therefore, the sodium electron configuration will be 1s2, 2s2, 2p6, 3s1. And the configuration notation provides an easy way for scientists to write and communicate how electrons are arranged around the nucleus of an atom. This makes it easier to understand and predict how atoms will interact to form chemical bonds. So now I'm going to proceed the valence. So sodium has one valence electron. The element has a full innermost electron shell of 2 electrons and a full shell of 8 electrons. In the next shell, the third shell, which is the outermost, and valence shell has only one electron. Valence electrons influence chemical reactivity. And now I'm going to discuss what is noble gases of sodium. A noble gas configuration of an atom consists of the element symbol of the last noble gas prior to that atom, followed by the configuration of the remaining electrons. So for sodium, we make the substitution of Ne for 1s2 and 2s2 and 2p6 part of the configuration sodiums. Noble gas configuration becomes Ne 3 is 1. Table below show the noble gas configuration of the third period element. So, thank you.
And I'm gonna discuss you about the electron configuration. So I choose the element of oxygen, and it has atomic number of 8, and it belongs to group VIA rather. So how to get the electron configuration of oxygen? So it would be the 1s2, 2s2, and 2p4, because oxygens belong to the p and it ends at 4. So so that would be your electron configuration, and the valence of oxygen is 6. That would be your valence number, and the answer and the core would be 2. So that would be 8 electrons minus 6 valence electrons is equal to 2 core. That's why I minus the atomic number and the valence electrons. So your core number would be 2. So how to get the noble gas configuration? So you have to combine the electron configuration. So that would be 1s2, 2s2, 2p4. So it ends at 2s2 and 2p4. So all you have to do is you will add the 2 and 4, that would be 8, and the answer would be helium 2 2s2 and 2p4. That would be your noble gas. That's all. Thank you.
Bromine's atomic number is 35, so need 35 electrons. Bromine is located here. So now we'll be starting to write our electron configuration for bromine. Starting with 1s. We fill the 1s with 2 electrons. And 2p with 6 electrons. Move to the third shell. We fill 3s with 2 electrons and for 3p with 6 electrons. Moving down to the fourth period, we will fill first the 4s orbital. We write 4s2 and also for the d orbital we write 3d10. And for the 4p, we will be writing 4p5 4p5 because bromine is located here, which is the fifth in the 4p orbital. To find the number of valence electron, we'd look for the highest value, which is the fourth energy level. Right here, we have 2, 2, and 5. So it is equal to 7. The valence electron for bromine is 7. To write the noble gas configuration, first we need to find bromine in the periodic table. So here's the bromine, then we move up row over the noble gas, which is argon. Its atomic number is 18, so it takes place of the first 18 electron, which would be 1s, which would be 1s to 3p6. So we write argon. So we write argon in brackets. Then write the remaining electrons, which is 4s2, 3d10, and 4p5.
Today I'm going to discuss you on how to get the electron configuration, valence electron, and noble gas electron configuration. First, let's tackle about the electron configuration for boron. To find the electron configuration for boron, first we need to find the number of electrons. To do that, let's look at the periodic table. So the boron is written this way. So we're going to use the sublevels. Did you know that there are 4 types of sublevels? So what are the 4 types of sublevels? So the 4 types of sublevels is S, P, D, and F. So S holds up to 2 electrons, and P holds up to 6 electrons, and D holds up to 10 electrons. And F holds up to 14 electrons. The sublevels orbitals are spaces that have a high probability of containing an electron. So we're going to use the sublevels to find the electron configuration for boron. First we have 1s2, then cancel, and then 2s2. Since we already have 4 electrons, we just need 1 more. So we have 2p1 equals 5 electrons. So this is the electron configuration for boron. How to find the valence electrons for boron? There are 2 ways to find the number of valence electrons in boron. The first is to use the periodic table to figure out how many electrons boron has in valence shell. To those who look at the group number, or groups are the columns, boron is in group 13, also called 3A, and therefore boron has 3 valence electrons. Note that this method doesn't work for the transition metals. So this is the second way to find the valence electrons for boron. You can also look at the electron configuration to determine the number of valence electrons for boron. So like 1s2, 2s2, 2p1. The number of electrons in the highest energy level like 2s and 2p will give you the number of valence electrons. Using this method will also determine that boron has 3 valence electrons.
And for the last one, the noble gas electron configuration. So the rule for writing the noble gas notation for something is pretty simple. It is you take the noble gas immediately preceding your atom or ion. So what do you mean by preceding? That means we want the noble gas that comes right before it. So you can go up row and you go over here where the noble gas live, and you put that in a bracket, and then you write your other electrons using the same notation that we normally use. Write an electron configuration.